Welcome back. In this mini lecture, we will look at service modeling. Recently, process modeling and process reorganization have been recognized as being of utmost importance for making e-government implementations success. Service modeling concerns the representation of the relations between services and the resources supporting them on the one hand, and the relations between services and the way in which they are made available to the users of the services on the other hand. The notion service modeling consists of many dimensions. The first one is the service itself. We discussed the definition in one of the first mini lectures. It seems fair to say that service is a well-defined immaterial entity which is provided by a party to other parties. A service typically needs resources to operate. Using the railway service as an example, it needs railway cars, engines, and tracks, for example. A resource by itself is not a service. A network of railway tracks needs to be complemented by the maintenance activities before it can be called a service properly. Track maintenance is an example of a service, which is usually not directly visible to the end user, but is used by another service, which is the railway transportation, which is directly visible to the end user. Service modeling is used to specify business operational requirements necessary to meet business goals and objectives. Service modeling is used also to help bridge the semantic gap between business requirements and the architecture of IT solutions that are intended to meet them. Service modeling provides a formal relationship between business process models and the model elements that realize them by treating each business process as a contract. The contract specifies service providers playing roles in a collaboration fulfilling responsibilities choreographed by rules for how the roles interact in order to achieve some business objective. Contracts provide a clearer separation between specifications of what has to be done from the many possible ways of doing it. Business application development often starts with business process modeling to discover and document the key business requirements that are necessary to meet business objectives. Business analysts often specify the system functional requirements using process models, while developers prefer to use object or service modeling to specify implementation models. How these different worldviews are reconciled and kept in sync as the applications develop in the face of changing business requirements is not well understood and can result in cost overruns and applications that don't meet customer needs. Integrating business and object modeling tools has been challenging because of conflicting perspectives and lack of formal semantics. So right now, what has been going on is the phase of testing and experimenting with different potential design and modeling tools to bring forth improvements. What is needed is a safe environment to see what could happen. For that, simulations and modeling tools are being used, such as object or agent modeling. Simulation tools are necessary to reduce wasting resources and identify unforeseen impacts of different scenarios. Any software application has to have a specification of what it does and an implementation for how it does it. Models can provide a relatively high-level way of describing both. However, we have to keep in mind that all models have their strengths and weaknesses. The challenge is to figure out how to use both to their best advantage, to avoid their deficiencies, and to reduce the overall work required to specify and build software systems. We can also talk about business process modeling in this context. This is the set of processes organized into catalogs. Each process represents the business operational requirements necessary. It also defines tasks and resources necessary. It can be relatively simple, focused on specific identifiable tasks, and result in clear business value. Workflow-based systems are meant for the setup, performance and monitoring of a defined sequence of tasks that are in turn arranged as a workflow. Business process modeling provides organizations with patterns of business activities that are enabled by a systematic organization of resources. Modeling can be done on processes that transform materials, provide services, and process information. We can also talk about service-oriented modeling. Service-oriented modeling is the discipline of modeling business and software systems for the purpose of designing and specifying service-oriented business systems with a variety of architectural styles, such as enterprise architecture, application architecture, service-oriented architecture, and cloud computing. Any service-oriented modeling methodology typically includes a modeling language that can be employed by both the business and the IT department. The unique perspectives typically influence the service development lifecycle strategy and the projects implemented using that strategy. Service-oriented modeling typically strives to create models that provide a comprehensive view of the analysis, design, and architecture of all software entities in an organization, which can be understood by individuals with diverse levels of business and technical understanding. Service-oriented modeling typically encourages viewing software entities as assets, so we are calling them service-oriented assets, and refers to these assets collectively as services. There are two approaches for service-oriented modeling. The first one is SOMA, Service-Oriented Modeling and Architecture, and the second one is SOMF, Service-Oriented Modeling Framework. There are different requirements to support the process of modeling services. Their purpose is the identification of actors and their roles, defining possible communication channels, making sure of the transparency of the flows, the standardization of terminologies. Also, these tools can be useful to ensure integrated modeling in all parts of the organization, but also integrating the citizen into the process. Additionally to these, service modeling incorporates areas such as system simulation, pathway analysis, benchmarking, and forecasting. But thank you for now, and stay tuned for the coming mini lectures.